Good morning students, welcome to the next lecture for binary subtractors using full adders. Here we are going to see the next concept of binary subtractors. So in the last class we have seen 4-bit binary adder. In the same way now we will see 4-bit binary subtractor, 4-bit binary subtractors but using full adders. Sir, why can't we take full subtractors for doing the binary subtraction process? It's very simple thing. When you are implemented hardware, so in the half subtractor and full subtractor concept, we discussed about borrow. But coming to that, I said in the first unit itself, when we are learning binary arithmetical operations, I said that there is no borrow concept in the hardware. Right? So when you want to do the subtraction process, there is no borrow concept. For doing the subtraction process, you have to take a complement of that subtrahend value. When you are doing the subtraction, A minus B, where A is equal to minute, B is equal to subtrahend. For subtrahend, you are changing, you are finding ones complement and twos complement. So by using complement methodology, we are doing. So after finding the complement of subtrahend, then you are doing the addition process. For example, A minus B operation is here. This is actually the subtraction. What we are doing, we are converting this one as A plus of minus B, and this minus B, you are doing the complement operation. It may be ones complement or it may be twos complement. So generally we are following twos complement methodology. So for the twos complement methodology, what you are doing, so here for B you are taking ones complement and you are adding one value. You are adding for the one value. For example, A value is equal to 0, 0, 1, 0 and B is equal to, for example, 1, 1, 0, 0. So these are the values given. Now we have to perform A minus B operation. When you want to perform this A minus B operation, first find the minus B value. Here you have to find the minus B. So you have to find the twos complement of B. So for the ones complement of B is equal to 0, 0, 1, 1. You are just reversing the values. You are reversing the values. Next, coming to here, when you want to convert it to twos complement, you are adding 1 here. So 0, 0, 1, 0. So this is the twos complement of B. So what you are doing here, for the given subtrahend B value, you are reversing. That is, if it is 0, you are changing to 1. If it is 1, you are changing to 0. Like that you are doing reverse operation and you are adding 1 to this ones complemented number. Okay, if you want, you can add like this also. A is equal to 0, 0, 1, 0. First write down ones complement B. Ones complement B you have to write here. Next write down the value 0, 0, 1 and you have to add 1. So you can add these 3 at a time. For adding this 3 at a time, you need a full adder. Sorry, for adding this 3, you need a full adder. So see here you have to identify where half adder is required, where full adder is required. I said that our concept binary subtractors by using full adders. For implementing full adders, you have to take the inverse of the B. Okay, so that is you have to find the ones complement of B and then you have to add. So this is the thing. So the same operation I am writing with using a generalized way, where A is equal to A3, A2, A1, A0. Here ones complement of B, here I am writing ones complement of B, where ones complement of B is equal to, here actually B3, B2, B1, B0 values are there for B. When you are finding the ones complement of B, here you will get B3 bar, B2 bar, B1 bar, B0. Actually, A is equal to, we know that A3, A2, A1, A0. Where B is equal to B3, B2, B1, B0. Okay, A value, B value, okay. But coming to, I said that ones complement of B. Here, you have to write down ones complement of B. The ones complement of B is equal to B3 bar, B2 bar, B1 bar, B0. And you have to add 1 for this. So this is the, now this is the generalized procedure. Okay, so this is a generalized representation. For adding these 3 bits, we need a full adder. So after getting some result, you will get carry also sometimes. So you have to add carry here. So now we will see clearly. A is equal to A3, A2, A1, A0. B is equal to B3, B2, B1, B0. Next, 1's complement of B is equal to B3 bar, B2 bar, B1 bar and B0 bar. So this is 1's complement of B, right? So this is full adder. Here also I am writing one more full adder, right? Whatever the concept we have discussed in the previous classes, the same concept here I am doing. Okay. So full adder, full adder, full adder. Okay. For full adder, we have 3 inputs. I am drawing these 3 inputs. So these are the 3 inputs. So this is the full adder 0, full adder 1, full adder 2 and full adder 3. Total 4 full adders I have taken and those are the inputs. Now coming to that outputs. So this is generally sum output. This is carry output. Okay. Sum output, carry output. Carry output, sum output. These are the outputs. This is S0, S1, S2, S3 and this is the final carry, C out. So these are the sum functions. These are the sum functions. So see here, I have drawn 4 full adders. For 4 full adders, 3 inputs are there. For each full adder, 3 inputs are 2 outputs are 2 inputs and 2 outputs. Sorry, 3 inputs and 2 outputs are available. So coming to that, here the full adder, I am writing A0 input, B0 input. Here I am writing A1, B1. Here I am writing A2, B2, A3, B3. So these are the inputs. Okay, A0, B0, A1, B1, A2, B2, A3, B3. These are the inputs. Now coming here, the inputs here. Coming to the inputs, here I am writing here C0. So carries I am representing with blue color. So C0 and after doing this, so see here, C0 we have represented. After adding this, you will get some C1. The C1 carry I am connected to the next full adder. Next full adder. And this is C2. This is C2 and this is C3 and this is the final carry. Okay, right? So now I have corrected. But actually, which value I have to give here? B0, B1, B2, B3 is a B value. But I have to give 1's complement. I have to give here B0 bar, B1 bar, B2 bar, B3 bar. For that what I have to do, right? For that I am doing here. Here my target is not giving B0, B1, B2, B3. My target is I have to give B0 bar, B1 bar, B2 bar, B3 bar. So for that I am taking an inverter here. So this is B3 and this is B2 and this is B1. This is B. Right? So here I am using adders only, but I am doing subtraction operation. Okay, if you are directly written B0 values, it will do the addition operation. When you are taking inverting operation, it will do the subtraction operation. So 1's complement of B I got. Now I have to add 1 for A0, B0. So see here, I have to add for A0, B0 1. So in the place of C0, I am keeping the value 1. In the place of C0, I am writing the value always 1. Okay, so I can add 1 here also. So it is very simple thing. I want to do the binary subtraction. For the binary subtraction, mind you, a is fixed. Coming to the subtrahend, you have to find the 2's complement of subtrahend. So for finding the 2's complement of subtrahend, that is equal to b, first find the 1's complement of b, then you have to add 1. So I have found this 1's complement, that is reverse values b0, b1, b2, b3 values I have taken with an inverter, and I am adding at a0, b0, the value is equal to 1. So in full adder, the value of C0 is always equal to 0, but in this subtractor, C0 is equal to 1. So remember one thing, wherever you go, you have to remember only one thing, that is when the C0 is equal to 1, then you are doing the subtraction operation. Where C0 is equal to 0, then you are doing addition operation. It is very, very important. So this is the topic 4-bit binary subtractor. This is the topic of 4-bit binary subtractor. Okay? Right. So see here, the same diagram I have represented here. So see here, something printing mistake happened here. So see here, I have taken A0, A1, A2, A3 values, and next I have taken B0 bar, B2 bar, B1 bar, B2 bar, B3 bar values. Then I have written C0 is equal to 1. So it is not visible. Now I am writing here. Remember that here for the first full adder, C0 is equal to always 1. The diagram, some part is not displayed in this board, that is the image cut, the image has cut here. Okay, no problem. The remaining portion I have written here, C0 is equal to 1 and A1, B1, A2, B2, A3, B3, and these are the sum 1, sum 2, sum 3, sum 4, these are the values. But you have to remember that these are not the finalized sums, these are the differences and final carry. So you have to remember this. Next coming that, in the next lecture we will see binary adder cum subtractor. In the next class we will see binary adder cum subtractor. In the same diagram you can do, if you want to do any binary addition or if you want to do any binary subtraction, that we will see in the next class. Thank you.